Okay, so chapter 7 is gravitations. Okay, so according to times students learning hours, we are going to spend 4 hours on chapter 7's tutorial. So 7.1 gravitational force and field strength. So in this first chapter, the things that we're going to look at is a force and a field strength. So what is a force? Force, according to the Newton's gravitational law, the law of Newton's law of gravitation, F is equals to G m over r squared. Now, what is a GMM over R squared? Capital letter M and small letter m. That is a very important thing in this chapter. Okay, in which it tells you one is belongs to the point mass and one is belongs to the test mass. But when it comes to force, it's still okay because you just need to know there are two masses. Okay, so you have two masses here, and then there's an attractive force between them. So it doesn't matter what is the object. As long as you have two forces, then there must be an attractive force between them. For example, between you and your friends, okay, you and your family members. So both of you, you got weight, okay. So you got weights and you got mass. So as long as you got mass, when you're standing close to each other, then there will be the attractive force between you and your friends, okay, and the other persons. Now, the only reasons why you don't feel it is because of the constant, the gravitational constant. Okay, the gravitational constant is very, very small. So the value is up to times 10 to the power of negative 11. So if you go back to the questions, so G given, now let's look at the bottom. G given is 6.67 times 10 to the power of negative 11. So if you use 6.67 times 10 to the power of negative 11, multiply with your mass, okay, for example, with is a 50 kg and 50 kg, then the value will still be very, very small. So in that case, your mass, okay, your mass, the force generated, the force created by your mass is not significant, all right, not obvious. So it can be negligible. Now try to imagine if you can feel the force between you and another person's, that would be horrible. Why? Try to imagine, okay, when you're walking around, then suddenly you are being attracted towards the other people's. Okay, so how are you going to walk properly? How are you going to move properly, move freely, right? So that is another issue. So force between two small masses is negligible. Therefore, usually we look at the force between a planet and the other object because the mass of planet is very huge. Now, when it comes to a gravitational field strength, which is A, okay, so AG is actually equals to F over M. Now, this M is a small letter m, right? Small letter m, what does it mean? It means the test mass, okay? So small letter m, this is our test mass. Capital letter M, this is our point mass. So what is the difference between these two? Point mass, usually it won't move in our system, all right? And test mass, you use it to test the value at different position. You move it around, it can be moved easily. All right, so that is the main difference between point mass and test mass. And another reasons why you have to know which one is test mass and which one is point mass. Now, AG equals to F over M. This one uses test mass, right? But if you expand the equations, AG at the same time is equals to G capital letter M over R squared. Well, now when it comes to these equations, the M that you're going to use is point mass. Okay, it's point mass. So you have a test mass and you have a point mass. You need to know which one to use for which equations. All right, so for force, it's not significant because you need two objects, you need two masses. So it doesn't matter whether you're looking at point mass or test mass. But when it comes to A, then you need to know whether you're given the mass of a test mass or the mass of the point object, the point mass. All right, because it will make a huge difference. And usually when it comes to these questions, all right, questions usually will give you a planet that is not moving, and then another things, for example, a satellite that is moving around, okay, or it just tells you a point that is maybe few thousand km above the planet. Then that point would be acting as a test mass because you are testing, okay, you are testing. So at that point, you place on a small object, maybe it's a humans, maybe it's a satellite, maybe it's a small planet. Okay, then that would be a point mass. Okay, now let's go back to exercise 1. So Tisha and Edwin, now you are given two persons with a mass 50 kg and 70 kg respectively. And both of them, they are sitting on a bench. They are separated by a distance 0.5 meter. So calculate the gravitational force between Tisha and Edwin. So how to calculate? Now, since I told you just now, between any two objects, okay, any two objects with masses, there will be an attractive force between them, which is known as a gravitational force. So we are going to apply F equals to G mm over r squared, okay, where it is equals to, now G given 6.67 times 10 to the power of negative 11. This value, you don't have to memorize it. It will be given. And then the two masses, the first one is 50 kg and the second one is 70 kg divided by 0.5 squared. All right. And then you are going to get a F equals to 9.34 times 10 to the power of negative 7 Newton. So as you can see now you have a very, very small force, okay, which the value is equals to 9 times 10 to the power of negative 7. Therefore, it is not significant and it can be neglected. All right. Therefore, you won't feel the force between you and another person. Okay, it is very, very small and it won't affect your daily life. Okay, so next, okay, but before that, I give you some times, maybe 1 minute to write it down, especially in terms of the equations for gravitational field strength. Okay, you have two different mass. One is test mass and one is point mass. You have to know which one to use. All right, which one to be used. So test mass, point mass, very important in chapter 7. Oh yeah, and one more thing that I forgot to mention just now, which is the R. Okay, the R usually we take from the center of a masses until the center of the other mass. All right, so if you have two masses, okay, then the distance will be from the center of mass 1 until the center of the other mass. All right, so it's very important. Keep that in your mind. This is your R. So 1 minute for you to write it down, okay, the important informations before we proceed to the next questions. Okay, so next one. Okay. So the average distance separating Earth and the Moon, okay, the Moon is a 38400. Now, if you pay attention to the unit, so you are given such a large numbers already, and it's still in terms of km, all right, which means you have to convert it into SI unit after this. So a spaceship of 3 times 10 to the power 4 kg travel from Earth to the Moon. Determine the distance of the spaceship from the Earth at which the net gravitational force acting on it is 0. Now, when it comes to these types of questions, if you look at these questions, okay, there are 3 different objects in the questions. We have the Earth, the Moon, and also the spaceship. But we have to know, which one is our main object. So how to know? Now you look at the question. Determine the distance of the spaceships from the Earth at which the net gravitational force acting on it is zero. Now, acting on which object? Acting on the spaceship. Therefore, our main object is the spaceships. Okay, so let's sketch a diagram. Now, I would encourage you to sketch a diagram in the chapter 7 as well. Why? Because the questions could be very tricky, especially when it involves more than 2 objects. Okay, for example, like these questions where you have 3 different objects. So now let's sketch the Earth. Okay, so this is our Earth, so with a ME, and then this is the moon. Okay, the moon. So which is a MM. So given the distance, now it gives you the distance. Usually when it says the distance, it means the distance is from the center. Unless the questions mention the distance from the surface of the Earth until the distance to a surface of the moon, then you need to calculate the distance from the surface. Then the value given is from the surface. But anyway, when it comes to calculation, you still need the value from center. All right, remember, R is always from center. So if you are given from surface, then it means you need to add the radius of the planet. All right. So from center to center given 384,000 times 10 to the power of 3 meter. So make sure it is in terms of meter. All right. So what happened next? Now you have a spaceships. Okay, you have a spaceships. And then you don't know where is the spaceships. Okay, so this is our spaceships. I'm just going to call it MS. All right, spaceships. So now if you look at this diagram, now we know in order to calculate the force, all right, we need to have a distance. All right, we need to have a distance. But before that, let's look at the questions again. Our main object, once again, our main object is the spaceships. So we need to identify the force acting on the spaceship first. So how do we know how many forces do we have in the questions? Okay, try to recall. Gravitational force is a type of attractive force. It exists between 2 objects. So which means the first things that we're going to look at, we try to look at what happened between these 2 objects. Okay, we ignore the moon first. We focus on the Earth and the spaceship. Okay, because spaceship is our main object, it needs to be included in every situations. So the Earth and the moon and the spaceship, there is an attractive force between them. Okay, and I'm going to call it Fe. And then the second part that I'm going to look at is now the relationship between the main object, which is the spaceships, and the moon. Okay, because there are 2 masses again. So what happened between these 2 masses? Of course, there is another attractive force between them. Okay, in which I'm going to call it Fm. All right, now in order to calculate force, we need distance, right? So the first things that we have, okay, now we are going to find out what is the distance between spaceships and the Earth. Well, since we don't have the value, right, that is the things that we want to calculate. The distance of the spaceship from the Earth. So I'm going to label it as X, right? So that is the distance between the Earth and the spaceship. Since it is an unknown, so I label it as X. Now, how about the distance between the spaceships and the moon? Well, I don't have the value, but then again, I don't want to call it as another variable. For example, Y. I don't want to call it as Y. Why? Because if you call it Y, if you give it another variables, another unknown, then you are creating more unknown in this situation. When it comes to problem solving, we try to minimize the numbers of unknown. Okay, so how are we going to minimize the numbers of unknown? Let's look at the diagrams that I sketched again. I know the distance between 2 planets, which is the Earth and the moon, is 384,000 times 10 to the power of 3 meter. And I also know that the distance between the Earth and the spaceship is X. So in that case, I can say the distance between the moon and the spaceship is actually equals to 384,000 times 10 to the power of 3, okay, times 10 to the power of 3 minus x. So in that way, I can keep the unknown at 1, okay? So I'm not going to generate a new unknown. I'm still keeping the unknown as just the x only, all right? I don't have any extra unknown, all right? I don't want the more unknown in my equation, in my questions, because that would make it hard to solve the question if you have too many unknowns. Okay, so kita kekalkan unknown sebagai satu saja, okay, satu unknown yaitu x. Kita tak nak unknown yang terlebih banyak. So kita tak nak panggil jarak antara spaceships dengan moon sebagai y ke atau sebagai any other alphabet. Okay, sebab semakin banyak unknown, semakin susah nak selesaikan soalan. So based on the diagram, I can say the distance between spaceships and the moon is 384,000 times 10 to the power of 3 minus x. Now, can I use the distance between ms and mn as x? Well, you can. Okay, you can say the distance between the spaceships and the moon is x, and then the distance between spaceships and the Earth is 384,000 times 10 to the power of 3 minus x. But then that would make require an additional step to solve the questions. Why? Because let's go back to the main question. Main question say determine the distance of the spaceship from the Earth. So at the end, you still need to calculate the distance between the Earth and the spaceship, which now is our x. Okay, kalau anda panggil dia sebagai 384,000 times 10 to the power of 3 minus x, then anda kena tambah satu step untuk kira dia, untuk kira final answer. Okay, so it doesn't mean that you are wrong. Okay, you can have here as 384,000 times 10 to the power of 3 minus x, and the distance on the other side of x. But then you need one additional step to find out what is the distance, okay, distance of a spaceship from the Earth. All right, so dia akan jadi susah. So we'll read the questions and then we try to simplify it, okay, by putting the distance between the Earth and the spaceship as x to make it easier, okay, to save one step. Oops. All right, so kita tak nak ini, okay, because this one, it will make you confused and it will add an additional step at the end. All right, so kita kekalkan original punya diagram. So now, how are we going to solve it? How are we going to calculate it? First of all, it tells you the net gravitational force acting on it is equals to 0. So this is very important information. Why? Because it tells you summations F is now equals to 0. Okay, so summations F acting on the spaceships is equals to 0. Now, what is the free body diagram for the spaceships? So if you look at a spaceship, this is the object, this is a spaceships. There are two forces acting on it. One is Fm, another one is Fe. Okay, and both of them, they are pointing towards opposite direction. All right, so in that case, what am I going to do? So now I'm just going to say, okay, Fm, the first going to the right, minus Fe is now equals to 0, because it tells you the total force acting on the spaceship is equals to 0, which means the force going to the left must be equals to the force going to the right in order to get summations F equals 0. So rearrange equations, you obtain Fm equals to Fe. Right? All right. So Fm, okay, Fm, what can I say about Fm? So Fm is the force between the moon and the spaceships. Therefore, G, now since it's the force between the moon and the spaceships, so I use the mass of the moon and the mass of the spaceships in my questions. So divided by r squared. So now my r is 384,000 times 10 to the power of 3. Okay, or I'm just going to make it easier by writing it as 3.84 times 10 to the power of 8. Okay, 3.84 times 10 to the power of 8. minus x, and then remember to square it. Okay, remember to square it. So usually students got it wrong because they forgot about the square, which is then equals to G. Now, Fe is the force between the Earth and the Moon. Therefore, GME, the force between the Earth and the spaceship, sorry. So GME ms over x squared. Okay, over x squared. Now, when it comes to this step, you're almost done. Okay, you're almost done. Just that you need to think, how are you going to simplify it? And also, there's an issue. We don't have the values for ns. Okay, we don't have the values of the mass of the spaceships. But when you look at this equation, now you have ms on the right hand side, and you also have ms on the left hand side. You have it on the both sides. So what you can do, now you can cancel it out. So cancel it out, and then you rearrange the equations. Eventually you will obtain x squared over 3.84 times 10 to the power of 8 square equals to, oh, g, you can also cancel it out because now you have it on both sides. So g, cancel it out. So on the right hand side, now you have me over mm. Now, when it comes to this step, okay, I want you to pay attention. Now, you don't have to expand the equations on the left hand side. Okay, you don't have to square the equations on the left hand side. Why? I would encourage you to put a square root here to make it easier to solve it. So square root both sides. Okay, square root both sides. Rather than you go and expand the equations and then you have unknown. Oh, one thing is missing. And you guys didn't notice. So it's minus x squared. So you don't expand the equation. If you expand the equations, then you are going to make it complicated. You will have a value with x squared, and then you have a value with just x, and then you have value without x. Okay, then that will make it very hard to solve this question. That will make it very hard to simplify it. The easiest way is to square root both sides. Okay, so this step is actually very important because it makes your life so much easier. So if you square root both sides, what are you going to get? So after you square root both sides, you will have just x divided by 3.84 times 10 to the power of 8 minus x. So you don't have to expand it. Okay, you won't have a square, okay, a square value. So nanti dia akan jadi susah bila kamu ada x square. Alright, so we square it both sides just to just to eliminate the x square. Okay, we keep x in our questions, in our solutions. So on the other side, okay, we have a square root. Now this part is easier. Why? Because you have the value. So if you look at the questions, given the mass of the earth is 6 times 10 to the power of 24, so divided by the mass of the moon, which is a 7.35 times 10 to the power of 22. All right, so square root value would be much easier, okay, compared to you go and expand the equations until you have a power, okay, a square value. So rearrange the equations, okay, you will then obtain x is equals to 3.46 times 10 to the power of 8 meter. Okay, 3.46 times 10 to the power of 8 meter. And that is the final answer. Okay, because the x here, it represents the distance of the spaceship from the Earth. All right, so that is the complete answer. So now I give you until 8:45 to write it down, because this is I would say this would be the hardest questions in a chapter 7. Okay, in a chapter 7. So if you can understand this question, then that is okay. Okay, this is a hot questions actually, a complicated questions. So make sure you understand, okay? Make sure you understand what does it mean by the net force equals to 0, how to label x, okay? And then how to generate unknown in the diagram. Make sure try to reduce the amounts of unknown in the questions. Okay, so you can sketch the diagram and then you write out the solution. And a very important step is the square root. Okay, make sure you know how to square root both sides. That will make your life so much easier compared to you go and expand it. Okay, so I give you until 8:45 to write down the complete solutions. Okay, to label the important informations in the questions. Okay, kalau ada soalan pastikan Anda tanya.
Madam,
Yep.
yang square root ME per MM tu kalau square root bukannya dapat plus minus lah?
Memang boleh dapat plus minus, tapi kamu sekarang tengok math kan? Math mana ada minus?
Okay, madam.
Okay, dan tambah lagi kamu square root both side. Kalau ada minus pun, kedua-dua side dia dah cancel out dah. Tak ada masalah pun. Okay, so next questions. This question is very similar to questions number 2. Okay. Calculate the net force on the moon due to the gravitational attractions of both the Earth and the Sun. If moon is between the Earth and the Sun during the solar eclipse. Okay, now if you look at the question once again, you have 3 objects. You have the Earth, the Sun, and the Moon. All right. Our job is to first identify which one is the main object. So now the main object, now if you look at the questions, calculate the net force on the moon. So which means moon is our main object right now. So even though you are given 3 objects, but the main focus would be on the moon. We want to find out what happens on the moon, okay, which is the net force, how to calculate net force on the moon. So let's sketch the diagram. Okay, so how to sketch the diagram? We have the Earth. Okay, and then this would be ME. And then the moon, which is MM. and then the sun, okay, the sun, which is ms. So based on Newton's law of gravitations, so you want to calculate net force acting on the moon. So what are you going to do? First, we try to identify first, okay, what is the directions of the force in between ME and MM? Well, it is an attractive force, okay, attractive force. So attractive force, this is our Fe. So Fe occurs between the Earth and the moon, all right? So first thing, we ignore the sun first, because every time when we want to consider the force, we just want to focus on two objects, and one of it must be our main object, which is the moon. So first thing, we look at what happens between the moon and the Earth, and then after that we try to identify what happens between the moon and the sun. All right, so again, there will be that attractive force between them. So this is Fs, okay, the attractive force between the moon and the sun. Now that I have both of them, what am I going to do next? I'm going to take the free body diagram. I'm going to sketch a free body diagram for the moon. So free body diagram, this is object, and then this is Fs, this is Fe. And according to the questions ask you to calculate net force, which means now net force is not equals to 0. Aha! Just now in the previous question, it tells you net force is equals to 0. But now when it comes to this question, it asks you to calculate the net force acting on the moon. So which means now your net force is no longer equals to 0, but it is equals to, based on the free body diagram, it is equals to Fs minus Fe. Okay, Fs minus Fe. So what are you going to do next? You're just going to expand the equations as usual. So Fs is the force between the sun and the moon. Therefore, G ms mm over r s m squared. Okay, and then minus Fe, which is the force between the Earth and the moon. So G m e m m over r e m squared. Okay, over r e m squared. Okay, now this, okay, when you reach this step, don't go and cancel anything. You cannot simply cancel G, you cannot simply cancel mass right now. Why? Because they are unequal. Okay, you cannot just cancel it in a calculations. So now you have summations F equals to this whole thing, and you cannot simply cancel out any items in the equations. It is unlike when you have one equations, when you have one of them on the right hand side and the other one on the right hand side. Okay, it is unlike this step. This step you can cancel it out because left hand side is equal to right hand side. But now when it comes to this step, okay, both equations, they are located on the right hand side. So you cannot simply cancel out the G and MM. What you have to do, you have to plug in the value. Okay, and usually when it comes to the mass of the planet and the distance between planet, it will be given as part of the known value in the questions. Okay, so basically you just plug in all of the value here, your mm, me, ms, and then the distance between E and M, which is your REM, and then the sun and the moon, which is your RSM. So you plug it into the equation, and then eventually you will obtain net force, which is 2.35 times 10 to the power of 20 Newton. Now, if you look at my free body diagram, I take Fs as positive direction, and my final value is positive value. Therefore, I know the direction toward Fs, which is towards the sun, is a positive direction. So final answer, when I obtain a positive value, it means it is toward the sun. Okay, toward the sun. Because I take, in my free body diagram, I take directions toward the sun as positive direction. Okay, this is toward the sun. The other side, the left hand side, is toward the, towards the earth. Okay, towards the sun. Okay, towards the Earth. All right, so when I have a positive value, then the final answer I need to state it is towards the sun. So this question is very simple if you understand what is the difference between these questions and previous question. Previous question, it tells you net force is equal to 0. This question, it asks you to calculate net force. When it asks you to calculate, then what does it mean? It means net force is not equal to 0. It has a value, and now the value is equal to 2.359 10 to the power of 20. All right, so I give you 3 minutes to write it down before we proceed to next exercise. Okay, you can write it down first, including the diagram, including the important notes. Okay, important notes in these questions.
Madam,
Yep,
I have a question.
yep,
Okay, let's say in my body diagram, let's say I were to interchange the position of my Earth and my Sun, and then the
Mhm.
free body diagram, let's say it'll be actually Fe minus Fs instead of Fs minus Fe. Will
that
it
is
affect
fine.
the answer? No.
That is fine. You will
Okay.
get a negative force, and then you just write one more sentence. It is
Ah.
2.35 towards the sun.
Okay. All right.
Okay, because these questions, you are not given the free body diagram. So it is up to you whether you want to put the Earth on the left-hand side or on the right-hand side. Okay, and also the sun. So yeah, it's totally fine if you want to use Fe minus Fs. Just make sure you know the directions of the final answer. Okay, right up to this point, we're done with a gravitational force. Next, we're going to look at gravitational field strength. Okay, we're going to look at AG. So in another word is also your accelerations due to gravity. Now, don't get confused. When we mention accelerations due to gravity, it doesn't mean that it must be 9.81. Okay, because every planet, they can have their own gravity, right? Not just the Earth. So when it comes to this chapter, some books they like to write accelerations due to gravity as g, but I don't encourage you to do so. All right, I'm going to stick to AG in my questions in my class rather than use G in my solution. Okay, if you watch a revision, if you watch other YouTube video, if you look at the revisions book, they like to use symbol G. For me, it's very confusing because G is our constant and it is equals to 9.81. So I don't like to use G in this chapter. Okay, so I will stick to AG. So kalau kamu tengok video lain dengan tengok video kelas kita nanti, okay, ada AG dengan ada G, so dia terpulang pada orang yang ajar kelas tersebut. All right, so in my class, to avoid confusions, I like to use AG. So I let you know first. All right, I let you know first. It doesn't mean that I'm wrong or other videos are wrong. All right, it's just we have a different preference. So determines the magnitudes of gravitational field strength at a point 5,000 km above the Earth's surface. Aha! Now you're given questions where it tells you you have a point that is 5,000 km. Okay, so again, you have the value in terms of km. That is the part that you need to take note. So 5,000 km above the Earth's surface. So now you have the Earth, and then this point, okay, this point is located, okay, is located at 5,000 km above the Earth's surface. Now, it doesn't mean that the distance starts from the center. If you recall, what did I tell you before? Okay, when it comes to this chapter, we want to use the distance from center, okay, from center to center. So this would be our R. So what does it mean? It means in your calculations for R, you need to add the radius, okay, the radius of the Earth, which is capital letter R. So magnitudes of gravitational field strength. So there are two equations like we discussed before. We have either AG equals to FG over M, or we have AG equals to G capital letter M over R squared. In these questions, obviously, we're going to use G capital letter M over R squared. Why? Because you're just given a point. Okay, you're just given a point and you don't have any information about this point. You're not given the mass of this test, the test mass, okay, at this point. So you cannot use AG equals to F over M because you don't have enough information. But what you can do, you can use AG equals to GM over R squared. Why? Because you have point mass, where your point mass is actually the mass of the Earth, okay, the capital letter M. Okay, so this is the mass of the Earth, which is a 6.0 times 10 to the power of 24 kg. All right, so how are we going to solve it? Questions, this is your questions A. So AG equals to, now GMM, which is a 6.67 times 10 to the power of negative 11. And then times with the capital letter M, 6 times 10 to the power of 24, divided by R. So R, you need to understand how to get the correct R. So this is very similar to one of the past questions, and quite a lot of students got it wrong because they forgot to add the radius of the Earth. All right, make sure you add it. So it's a 6.4 times 10 to the power of 6 plus 5 times 10 to the power of 6. Okay, times 10 to the power of 6. So because of 5,000 km, so it's 5 times 10 to the power of 6 squared. Okay, so press the calculator, you will obtain, okay, you obtain 3.08 ms negative 2. All right, 3.08 ms negative 2. So this is for questions A. Questions B, again, we're just going to use the same equation, but now it's happening on the Earth's surface where you're just going to use a capital letter R. So AG is now equals to GM over capital letter R squared. So you sub the value and eventually you will obtain 9.77 ms negative 2. Okay, 9.77 ms negative 2. So as you can see, it's very close to our theoretical value. Okay, the reasons why it is not equal to 9.81, it could be because maybe the radius that we are using here is already been rounded up, or the mass here is already been rounded up. All right, so yeah, it's very close to 9.81. So that is how we obtain the values of our accelerations due to gravity for the Earth, right? By applying these equations. Oh yeah, speak of the values of M and R, okay? You don't memorize it. So untuk nilai M dengan R kamu jangan hafal. Why? Because different books, they will give different value. So we use the values given in the questions. Now, sometimes if you look at the questions will give you a value. For example, the constant G. This constant G actually is in the list of constant. And sometimes questions will give you again. And they might give you a value that is different than the list of constant. So what should you do? Remember, first priority is given to question. Okay, so for example, if questions give you G equals to 6.7 times 10 to the power of negative 11, but list of constant give you 6.67 times 10 to the power of negative 11, then in our calculation, we use 6.7 because that is given in the questions. Okay, if questions didn't give you the value, then you refers to the list of constant. That is your second priority, right? First priority is the questions. Second priority is the list of constant. If both of them, okay, if you cannot find the value find the values from both questions and the list of constant, then you use your own value, the value that you memorize. Okay? So dia punya susunan begini. Kalau nilai ada dibagi dalam soalan dan nilai yang diberi tak sama dengan nilai dalam list of constant, kita mesti guna nilai dalam soalan. Alright? So kalau nilai tidak dibagi dalam soalan, baru kita guna nilai dari list of constant. Dan kalaulah dia tidak diberi dalam soalan atau list of constant, bermaksud itu nilai yang Anda kena hafal. So Anda guna nilai yang Anda hafal. Okay, so itu dia punya priority bila kita jawab soalan. Right, so I give you 2 minutes to write it down. Make sure you sketch this diagram. Okay, it is very important because students always got the wrong R. So if you got wrong R, most probably you are going to get the whole questions wrong. Okay, because the calculations in chapter 7, they all uses R. Semua perlu nilai R. Once kamu punya R salah, tak payah tengok 7.1 ke 7.2, 7.3 atau 7.4, semua soalan akan terus salah. Okay, semua soalan akan terus salah. So make sure you sketch the diagram. It is very important to show you how to determine the right R. Okay, so now let's proceed to the next questions. Okay, this question is a very interesting question. Okay, well, it is a questions that I would say that is no value. All right, like where you have to form two equations to simplify it. So this is a typical type of a ratio questions. So the mass and the radius of the Earth are 81 and 4 times respectively to the moon. What is the gravitational field strength on the surface of the moon? So the key point in this question, it tells you the equations that you need to use is gravitational field strength equation. Okay, gravitational field strength equation. That is the first thing that you need to know. Which equations to use, how to form equations. Okay, how to form equations when it comes to a ratio type questions. And then another two important piece of information is the ratio of the mass and ratio of radius are given. So now let's see how are we going to solve it. First of all, we need to form equations. Okay, so the mass of the Earth is 61 times respectively to the moon. So the first equations that we need is ME over MM is equals to 81. That is the first piece of information, the first equations that we have. The second one that we have is the radius. Okay, radius where RE over RM is equals to 4 times. Oops, just write 4 is enough. Okay, so it's equals to 4. So 81 and 4, that is the first things that we need to know. Okay, now the second thing, okay, the second thing for the Earth. Now, since the question tells us we need to calculate the gravitational field strength, so why don't we form equations for them, right? So AG, okay, the gravitational field strength for the Earth is equals to GME over R, now I'm going to call it RE, okay, RE squared, okay, RE squared. Because the question is asking for on the surface. So you just take the radius of the Earth is enough. So this is the first equation. Now the second equation is for the moon. So AGM is equals to GMM over RM squared. All right. So I'm going to use this one as my first equation and this one as my second equations, okay? Because they are unknown, they have no value. Now, when it comes to these types of questions, the ratio types of questions, usually we need two equations. And after we obtain both equations, we're going to use these two equations to divide to divide by each other, okay? So what am I going to do next? I'm going to use 1 divided by 2. Okay, I'm going to use 1 divided by 2. The reasons why we divide them is to eliminate the unknown in our equations. Okay, the same unknown in both equations. So now let's see. I have AGE divided by AGM equals to GME over RE square divided by GMM over RM square. Okay, so I'm going to simplify it first. So AGE over AGM is then equals to GME over RE square times RM square over GMM. Now, what am I going to do right now is I'm going to cancel out the G, okay, because they are the same for both equations. So G, I can now cancel it out. Okay, now next step, okay, this is a bit tricky. Okay, next step, actually you have 2 ways to solve it. Okay, kamu ada 2 cara untuk selesaikan dia. Actually, I'll show you both of them. Okay, I will show you both method. So, yeah. So first method, oops. First method, what am I going to do? I'm just going to rearrange the equations. Okay, so method 1. Okay, method 1, I have AGE over AGM equals to, now I'm going to rearrange them because why? Because I'm given ME over M and also RE over RM. So I'm going to rearrange it until it obtain the same form as the ratio given. So ME divided by MM is equals to, oops, is times, okay, times RM squared divided by RE squared. Okay, so which is then equals to 81 times 1 over 4 squared. Okay, because given RE over RM and now we have RM over RE, so it becomes 1 over 4. So eventually you will obtain 1.9 Newton kg negative 1. So this is method 1. Then how about method 2? Now method 2, okay, method 2, you just need the value. Sometimes students, they cannot think about this, okay? They cannot rearrange the equations until they obtain this form. So what they can do, now you can do it in a method 2. Okay, so method 2, you need to rearrange the equation first. So ME is then equals to 81 mm. And then RE is equals to 4 rm. All right. Then you sub these two into the equations above. Okay, you sub it in these equations. So what are you going to get? You will get AGE divided by AGM equals to, now ME is 81 mm. So 81 mm divided by mm. Okay, and then times Rm. Rm, I'm going to keep it. Rm square divided by bracket. Remember the bracket. 4 Rm square. Okay, 4 Rm square. So if you expand these equations, what are you going to get? It is actually equals to 81 mm divided by mm times Rm square divided by 16 Rm square. So next step, you just cancel out the unknown. So mn, oops, wrong color. Okay, and you can cancel it out. Rm square and Rm square, you can cancel it out. So it becomes 81 divided by 16. So eventually you will obtain 1.9, okay, and kg negative 1. Okay, and kg negative 1. Oh yeah, one more thing. I forgot one step. Actually, you won't get 1.9 yet. Okay, that is my bad. So what next? Okay, what next? Actually, we need to add one more step. So AGE is the Earth. Earth is 9.81, okay, over AGM. Right? So this is your 81 divided by 16. So AGM is then equals to 1.9. Okay, sorry, that is my bad. I missed out one step. So same things happens for method 2. Okay, method 2 pun benda yang sama. So you will have a 9.81 divided by AGM, which is 81 divided by 16. So AGM is then equals to 1.9 and kg negative 1. All right, so AGM, the value is, AGE, the value is fixed because it's the gravitation, the accelerations due to gravity for the Earth, which is 9.81. Right? So AGE dia punya nilai actually adalah fixed. Okay, AGE is 9.81 ms negative 2. Okay, so we are done. Okay, now that I've showed you both method, I want you to write down both of them. Okay, so in case you forgot one of it, then you still can use the other one. So especially method 2. Okay, method 2, you need to use it in quite a lot of situations. Okay, when the questions give you, okay, A is 4 times of B, B is 4 times of C, and so on. Then method 2 would be very useful. Okay, method 2 is very useful. So I give you, 5 minutes. I give you 5 minutes to write it down. Make sure you understand it. Sebab soalan ratio biasanya dia susah sedikit. Okay, pelajar dia tak berani jawab sebab tak diberi nilai apa-apa. So I give you 5 minutes to write it down. Make sure you understand, okay, what is the difference between method 1 and method 2, especially method 2. Method 2 is a more general method that can be used in any situations. Okay, so kalau dah siap, anda boleh rehat sekejap. Kita sambung balik pada 9.20. Okay, untuk masuk ke exercise 3. Alright, so let's look at 7.2. Seven point two, gravitational potential energy. So what is gravitational potential energy? So it means the work done needed to place another object inside the gravitational field of the other object. So for example, now I have one mass. Okay, so this is my point mass, I would say, because initially it's already in the system. So what am I going to do now? I'm going to bring a test mass. Okay, so for example, the field of a point mass is just up to this point. Okay, so this is the field of this point mass. All right. So outside this point mass, then it won't feel anything. Okay, it won't feel the gravitational force and so on. But what am I going to do now? I'm going to place another test mass inside this field. Okay, so the energy needed to put a test mass inside this field is the gravitational potential energy. Okay, it's the U. So U is also known as the potential energy of two objects, okay, of these two masses, right? So initially, point mass is in the system, but test mass is not in the system. So I'm now taking the test mass from outside the field into the field of the first point mass, okay, into the field of point mass. So in this case, the energy needed, we call it U, which is a GMM over R, okay, which is GMM over R. So that is what happened between two masses. And when this test mass is being placed in the field, then these two masses, they will start to experience gravitational force between them. All right. If M is outside the field, then they won't have a gravitational force between them. So this is the gravitational potential energy. Now, in another case, what happened is we move the test mass. Let's say now this is a test mass as 0.1. Okay. So this is a test mass as 0.1. Now we move it to a 0.2. But these 2 points, both of them, they are located inside the gravitational field of the point mass. So what can I do? I can say now my U is equals to GMM bracket 1 over R final minus 1 over R initial. All right, 1 over r final minus 1 over r initial. Or I can say it's actually equals to u equals to u2 minus u1. Okay, u2 minus u1. So this is what happened. Okay, this is what happens when I have two test mass. When I move the test mass from one point to the other point inside the field. All right. Okay, so next we're going to see how are we going to solve it. Okay, how are we going to solve it? So yeah, I think there's a oh wait, I missed our negative sign. Okay, u should be a negative value. So negative GMM over R, and now when it comes to the last equation, it should be negative GMM 1 over R final minus 1 over R initial. Okay, you have a negative value there. So that is the work done to bring one object. Okay, if you just have a negative GMM over R, then that is the work done to bring one object from outside the field into a field of one object of the point mass. Now, if both of them, they are already inside the field, but you move it from one point to the other point, then you use the second equations. Okay, where you have a negative GMM bracket 1 over R final minus 1 over R initial. So now let's look at the first questions. Determine the gravitational potential energy. Okay, let me zoom it in. Okay, so determine the gravitational potential energy of the Earth due to the moon only. So now you want to calculate the gravitational potential energy of the Earth and the moon. Okay, now you have two objects. So two different objects. So it's very simple. You just apply U equals to negative GMM over R. Okay, over R. So you plug in the value. Okay, you plug in the value. Eventually, you will obtain negative 7.63 times 10 to the power of 28 joule. Right, the gravitational energy of the Earth due to the moon. So this is the energy needed to place the moon inside the field of the Earth. And then questions B. Okay, the gravitational potential of the Earth due to the sun. So it is equals to negative GMM over R, which is then equals to negative 5.32 times 10 to the power of 33 joule. All right, this is the gravitational energy of two objects. So remember to select the right M. First one is what happens between moon and the Earth. Okay, what happens if you want to place the Earth on inside the field of the moon, or if you want to place the moon inside the field of the Earth, then this is the energies that you need, 7.63 times 10 to the power of 28. When it comes to the sun and the Earth, then you need more energy. Okay, you need more energy. More work need to be done to place them close to each other. Okay, to place them at a distance separated by this one. Okay, 1.5 times 10 to the power of 11. So now place Earth pada moon di jarak 1.5 times 10 to the power of 11 meter, kita memerlukan this much of energy. Okay, this much of energy. 5.32 times 10 to the power of 33 joule. So this is questions 1. Question 1 is very simple. Okay, question 1 is very simple. You just apply the equations, then you get an answer. So I give you 1 minute to write it out. You can try to calculate it by using the values given. So the values given here is not the radius, it's the radius of the orbits. Okay, of the orbits around the Earth. So including the radius of the Earth. So the other one is the radius of the Earth orbits around the sun. Okay, so it's including the radius of the sun already. Okay, so kena tengok perkataan yang dia bagi. Perkataan yang bagi begini bermaksud dia sudah kira dari center of the object. So 1 minute for you to write it down because this is just a very simple questions. Okay. Questions number 2. If a satellite of mass 800 kg falls from a height at 400 km to the surface of the Earth, what is the loss in gravitational potential energy? Now, it wants you to calculate the change in potential energy. You are given the satellite, it is moving at 2 different positions inside the field of the Earth. So this is the Earth, all right? So this is your E. So initially your satellite is somewhere here. Okay, it is somewhere here. So this is your satellite. It is located at a height that is 400 km from the surface. Okay, 400 km. So 400 times 10 to the power of 3 meter. This is initial, right? Initial. And then what happened after is it drops. Okay, it falls from the 400 km to the surface of the Earth. So this is the surface. Okay, this is the surface. So this is the final position. All right, so you have initial positions, you have a final positions. So what are we going to do next? So we need to calculate the potential energy at 2 different positions. Why? Because the question asks you to calculate the loss in gravitational potential energy. So you need a final and you need an initial. Okay, so what are we going to do right now? Delta U is equals to negative GMM bracket 1 over R final minus 1 over R initial. Right? Now, R final is what? Well, if you look at the finals positions, okay, the final position, now object is located on the surface of the Earth. So what happened is just the radius, the distance is equals to the radius of the Earth. All right, because remember, R, we always calculate it from the center of the Earth. But for initial positions, then you have to be careful. Okay, because you're given 400 km from the surface, then you need to add the radius of the Earth, the RE. Okay, the RE. So the equations, we can then expand it into negative GMM bracket 1 over, now R final is just your RE, the radius of the Earth, and then minus 1 over, this is RE plus, well, 400 km is 4 times 10 to the power 5 meter. Okay, 4 times 10 to the power 5 meter. So now you plug in the value, all the constant value, the G, the M, the R, they are all constant value given in the questions. Then you should be able to obtain negative 2.95 times 10 to the power of 9 joule. Right? So this is a slightly different than the previous question. Previous questions, now what happens if you want to place 2 objects at their current positions? Okay, so you want to place the moon and the Earth at a distance that is 3.84 times 10 to the power 5 km apart. And what happens if you want to place the Earth and the Sun at a distance of 1.5 times 10 to the power of 11 meter apart? So this one, you just calculate the potential energy between 2 objects. And now you want to calculate what happened if you move the point mass, the test mass, sorry, if you move the test mass from one point to the other point. So the test mass right now obviously is your satellite. The point mass is the Earth. So now you move the satellite from a point that is 400 km above the surface until the surface of the Earth. So you have an initial case and you have a final, okay, initial and final positions. So before and after, before it drops and after it drops. Okay, so make sure you are clear what is the difference between these 2 questions. Okay, apakah perbezaan antara 2 soalan ini? So I give you 3 minutes to write it down. Make sure you try to calculate it and make sure you sketch the diagram so that you can see what happened. Okay, you can see what happened before, after, final, initial. So 3 minutes for you to write it down, including the diagram, and then try to calculate, see whether you can get the answer or not. Okay. So make sure you sketch the diagram, yes, because all the diagram that I'm showing in the class, it will help you to understand the questions better. Okay, kamu jangan duduk di sini tengok-tengok saja, tapi tak ada diagram dalam jawapan Anda. Alright, now questions number 3. Okay, questions number 3. I think this is also the final questions for today's sections. Yeah. Okay, questions number 3. After questions number 3, I will let you guys go. And then tomorrow, I will finish exercise 4 and exercise 5. Okay, tomorrow we got class, right? Yeah, tomorrow I will finish exercise 4 and exercise 5. And then if we have times, then I will go through the UPS questions with you guys. Okay, because UPS questions, quite a few of you score, I think less than 50%, I think. Okay, so I hope that I can go through the questions with you guys. And chapter 8, you try to watch the video first. If you have any questions, then you can ask in the group. Okay, ask in the group so that everyone can learn together. Try to avoid PM. Okay, because PM to P, then only you yourself learn. Your friends learn nothing. All right, try to ask in the group. Makes use of the group. Okay, don't be shy. They are your classmates. Okay, they are your classmates. So questions number 3. The moon has a mass of 7.35 times 10 to the power of 22 kg and a radius 1740 km. So again, you are given km. So in this chapter, you have to be extra careful with the distance, the radius, and so on. Because quite often, the questions will give you the value in terms of km, and you yourself need to change it into meter. So determine the gravitational field strength at the surface. Okay, so now you want to determine the value at the surface. So this question is very simple. You just apply the radius. So AG is equals to GM over R squared. Okay, so which is a G is a 6.67 times 10 to the power of negative 11 times with the M 7.35 times 10 to the power of 22 divided by R. Okay, now remember you're given in terms of km. So it's 1.74 times 10 to the power of 6 meter square. Right? And then you will obtain 1.62 and kg negative 1. Now, sometimes students will ask me, can I use the ms negative 2? Yes, of course you can. Okay, you can use 1.62 times 10, 1.62 ms negative 2. Okay, both unit, they are the unit for gravitational field strength. So both of them, they are correct. Questions B. A probe of mass 100 kg is dropped from a height that is 1 km onto the moon. Okay, calculate the change in gravitational potential's energy. Okay, so what happens now? So you have an object that is located just 1 km above the moon. So this is your moon, and then this is a probe. Okay, some things like a satellite. Okay, so you have a probes. So this is a mass, and then the distance from the surface until the probe is 1 km. Okay, it's 1 km. And then the questions ask you to calculate the change in gravitational potential energy. So initially, it is 1 km above the moon, and then it drops onto the surface. Okay, so this is the surface. Okay, object from 1 km to the surface. So this is your final positions. So again, this is the moon. So it is very similar to the previous questions where you're going to calculate a change in potential energy. All right, delta U equals to negative GMM bracket 1 over R final minus 1 over R initial. So which is then equals to negative GMM, okay, bracket. Your R final, well, is on the surface, therefore it's just 1.74 times 6, 10 to the power of 6. And then minus 1 over, okay, now you have a 1 km. So 1.74 times 10 to the power of 6 plus 1 times 10 to the power of 3, okay, because 1 km. So you plug in the value, the mass of the moon and the mass of the probe. Eventually, you will obtain negative 1.62 times 10 to the power of negative 5 joule. All right. So this is the answer for questions B. Okay, this is the answer for questions B. And then questions C. Question C. If all the gravitational potential energy, okay, all the gravitational potential energy loss is being converted to kinetic energy, calculate the speed at which the probe will hit the surface. So what are we going to do? Okay, how are we going to calculate it? So in this case, okay, the change in kinetic energy is equal to the change in potential energy. Why? Because we know energy can only be transformed from one form to the other form. Okay, it cannot disappear. You cannot create an energy, or you cannot destroy an energy. What can happen is it's transformed from one form to the other form. All right, to the other form. So what happens here is we have a K final minus K initial equals to U final minus U initial. U initial, not final. Okay, minus U initial. Right, and then what happened is that now, well, I think you don't even have to calculate delta U because we have delta U in the previous questions, right? So yes, I think you can just keep it. You can just leave it in a delta U form because you already got it in the previous questions. Delta U is equals to negative 1.6 times 10 to the power of negative 5 joule. Now, K final and K initial. What happens in this K final and K initials? If you look at these equations, initially your object is from a height. Okay, initial is from a height that is not moving. So K initial in this case is actually equals to 0. All right, it's equals to 0. So you have a K final is equals to negative 1.6 times 10 to the power of negative 5 joule. All right, you have the same kinetic energy. So from here, you can then calculate speed. 1 over 2 mv squared equals to negative 1.6 times 10 to the power of negative 5. So from here, you then rearrange the equations. Okay, you then rearrange the equations. And eventually, you will obtain V equals to negative 56.92 ms negative 1. All right, so the speed, so you want the magnitude, therefore the speed is 56.92 ms negative 1. Now the reasons why negative, because it's dropping. So if it is dropping, mean it is going downwards. All right, so the reasons why you obtain a negative V here is because of dropping. And the energy, the change in energy. Now change in energy, actually you don't put negative. So okay, that is my bad. Don't include negative here. You are just looking at the magnitude because it's a scalar quantity. Okay, it's a change. You are not looking at the directions. You are not looking at whether it's being transformed into or transformed out. So it's just a positive value. Okay, so that is my bad. But the final answer, it should be a negative value because it's dropping. Because when you square root it, the velocity is plus minus. So you choose a negative value. Just that when it comes to speed, you just write it as positive. Okay, so change in K is equal to the change in U. They have the same value. Okay, they have the same value. Right. So now you write it down. Okay, now you write it down. So this whole question number 3. Question number 3. Okay, kamu sendiri zoom di device kamu. All right, so write it down. Then if you have any questions, you may ask. If no questions, I think that's all for today. Okay, I'm not going to enter escape velocity with you guys because that would be too much for you to do 4 subtopic in one day. Okay, so we try to start here. 3 subtopic. If you have any questions, you may ask. Okay, kita dah tengok. We have seen what is a gravitational force, what is the gravitational field strength, and now we have seen what is a gravitational potential energy and how to calculate it. All right. And then the next lesson, we're going to look at escape velocity as well as the information related to satellite. Okay, the speed of the satellite and also the periods of satellite, which is related to chapter 6. So 7.5 is something that has to do with chapter 6, the circular motions. All right, so I think that's all for today. If no questions, you may leave the class.
Thank you, madam.
Thank you, madam.
Okay.